Now that we've set up the basics of our fixed perspective room system, let's get on with the juicy parts, making the world do stuff. In this tutorial, I'm going to show you how to set up puzzle objects and how to create a basic 4-tumbler combination lock. As before, we'll need Blender to create the lock and puzzle objects. I'll also use Visual Studio Code and Python to automatically crop my rendered images. With Python installed, you'll need to also install the pill pip. Again, this part isn't necessary, but it will just make your life a lot easier and save tons of time. Don't worry, I'm going to provide you with the exact script I use to crop my images later in the video. A good puzzle, or at least a decent puzzle, requires you to piece together multiple sets of information to discover a solution. There are hundreds of different types of puzzles, but a good puzzle is never as simple as find this information here and copy it over there. A piece of paper with a cipher on it saying frog is A and bird is D is not a puzzle because you didn't have to interpret the information that you were given. Before building a puzzle in your game, first make a paper prototype. Fun fact, Myst was run as a session of Dungeons & Dragons with all the puzzles worked out on paper before any of the gameplay was ever implemented. This allows you to discover what works before committing to hours of development, only to find out your players don't understand something you thought would be obvious. I like to base all of my puzzles around a unique environmental interaction. In this case, I was walking along the beach and picked up a stone. I thought, wouldn't it be interesting if every time I skipped the stone, it skipped only a set number of times? This idea formed the basis of my puzzle. Here's the full idea, as implemented in the game. There are 4 piles of stone. Each stone has a symbol carved onto it. When the stone is thrown into the pit, it ricochets a set number of times. The number of times the stone ricochets can then be matched to the symbol on the lock on a power box. Open the power box and we can turn a switch that plays the end cutscene. So, how do we achieve this? Let's quickly go over what we need to build the system I have in mind. We need a 4-digit combination lock where we input the puzzle answer. We need it to unlock when the correct combo is input. A power box, which only opens if the lock is in the open state. A switch, which when clicked on, plays the end cutscene video. 4 separate stone pile objects, which when clicked on, play a video of the stone being thrown into the pit. In an earlier tutorial, the room system, we created a type of zone object called zone examine. We'll be using those zones today. Create a new object called obj underscore zone underscore examine underscore parent. In the draw event, paste the following code so we can see it if the debug mode is active. Make 4 more objects, each with the zone underscore examine sprite, and make the parent the obj zone examine parent object. I'm going to place these examine objects in the rooms where I'd want the player to click on the stone piles. The code in each of these objects will be very similar. I'll show you the first one. Make a create event. In the event, I've specified an exit location. This basically says, once I've clicked on the object, it will run its code, and when it's done, it'll put us back in a certain location. In my game, that location is N4, node 4. Make a left released event. This event will obviously run when we click on the zone. In the code, I'll write instance underscore create underscore depth, parentheses x comma y comma 0 comma obj underscore vid underscore stone 01. What this does is create a new video object which will play an animation of the player picking up the stone and then throwing it. If you missed how to play back video files, I went over it in the previous tutorial. Let's make another object. I know we're making a lot of objects, but just stick with me. And call it obj underscore vid underscore stone 01, since it's going to play the stone 1 video. I'm going to duplicate the code from my previous N3 to N4 walking animation and make some slight adjustments. Inside this video object, I'm going to make 2 alarm events, alarm 0 and alarm 1. In the create event, I'm going to set alarm 0 to the frame I want the video to pause at. Also, I'm going to add the line click underscore to underscore throw equals false. Inside alarm 0, I'll write video underscore pause, click to throw equals true. The video will pause on this frame, and now click to throw is true. I'm adding this because I want the player to simulate choosing to throw the stone into the pit. Finally, I'll make a global left released event. If click to throw equals true, open brackets, click to throw equals false, video underscore resume, alarm 1 equals 180, close brackets. The player clicks, the video continues playing, showing the stone being thrown into the pit. Alarm 1 is set to the remaining number of frames in the vid file. When the alarm 1 event finishes, we unlock the cursor and destroy the video object. We're right back where we were in node 4, facing the stone pile. Here's what that looks like put together. I click on my invisible zone examine object. The video starts playing. At frame 232, we pause. I press the mouse button. The video resumes and plays for a set number of frames. When it finishes, the video object is deleted, and I'm back in front of the stone pile. The other stone pile objects function in the exact same way. Moving on to the lock. We need 2 new rooms and 2 new locations. The first location will be powerbox, associated with rm underscore powerbox. The second will be lock, which is associated with rm lock. The exit locations for every index within my lock location are powerbox, since we're technically zooming back out to view the whole powerbox. And within the powerbox location, the exit takes me to a location I will call near lock, which is just another node. Remember, whenever we make a new place in the game, we have to define the location in our global controller object. In my powerbox room, I've done something a little different. Since I want the powerbox to animate open, I made the background a new object called obj underscore powerbox, and I gave it 2 sprite indexes, a state when it's closed and a state when it's open. I made a new zone object and placed it over where the lock is. This is called obj zone examine lock. Inside the create event of that object, I've set the depth to 1 and the exit location to the lock location. Remember, examine zones simply execute some code and then take us to a location. That's all they do. In this case, we want to go to the lock location when the zone is clicked on, so I've set exit location to lock. I made a new room called rm underscore lock. This is the room where the player interacts with the lock and inputs the combination. The background is a new object called obj lock controller. For its sprite, I made a render of the lock face without the tumblers. The tumblers will each be separate objects, which have to animate independently, so we'll make them separate. The background sprite has 2 states, one where the latch is closed, and a second where it's open. Now we need our 4 tumblers. Yes, I'm aware I spelled Tumblr like the website. Spell it correctly if you want. I don't care what you do with your life. We're going to make 4 separate Tumblr objects, each with an image sprite that shows the Tumblr set to digits 1 through 9. I've omitted 0, but it works the same way regardless of how many numbers you want for your lock. You'll need a separate sprite index for each position. In Blender, I've made an animation rotating my 4 tumblers to each lock position. It looks like this. In Blender, I've set my rendered area to only the section of the lock with the tumblers, and I've rendered it out as a PNG sequence, which gives me this. But wait, I don't want them all to move together. I need each tumbler piece to be cropped separately, so I can use it as my object sprite. Well, here's where the Python script comes into play, and I cannot stress how much time this will save you. First, make a backup folder. Now, make a new folder with each of the tumblers, 1 through 4 in this case. Duplicate those folders and label them Tumblr 1 out, Tumblr 2 out, etc. You're going to tell the Python program to take the images from the Tumblr 1 input folder and then output the automatically cropped images inside the output folder. The Python script is included, along with this entire example project, in the link in the description, so please check it out. Here's the stuff you need to worry about. Set the input folder to your Tumblr input folder file location. Set the output to your output folder here. Then define the cropped region of the sprite. So imagine you're defining the pixel coordinates of a rectangle, defining the left, upper, right, and lower sides. That part might need some tweaking, but the great news is you can run this script as many times as you want without losing anything. If all goes well, you should now have 4 perfectly cropped Tumblr animations, which you can input as sprites into 4 new corresponding Tumblr objects. I will let you do that now. Let's go over the code of our shiny new Tumblr objects. So I'm inside obj underscore Tumblr underscore 1. So I've got my 4 Tumblr objects. These 4 objects are exactly identical. The only thing that is different about them is that they have different sprites, right? So in the create event, we're going to write current number equals 1. So that's the number that's going to be displayed. My lock doesn't start at 0, but if your lock started at 0, then it would make sense to start your current number at 0. Image speed equals 0 because we don't want the lock's animation to play, and image index equals 0. Then we'll make a step event. So I want it so that if the player clicks on the bottom of the sprite, it's going to rotate clockwise, and if they click on the top, then it's going to rotate counterclockwise. So this is how you do that. So if parentheses mouse check button pressed, mouse button left, and position meeting mouse X, comma mouse Y, comma ID, open brackets, if mouse underscore Y is less than Y plus sprite underscore height divided by 2, then another brackets, audio play sound, and then I have it play SND lock click, priority 1, and it doesn't loop. Then I set current number to minus equals 1. Else, brackets, so close brackets, else, open brackets, audio play sound, sound click, priority 1 false, current number plus equals 1, close brackets. All right, so that's going to rotate that lock. Then we're going to limit the lock values. So if the current number is less than 9, if the current number is greater than 9, current number equals 1. And if the current number is less than 1, current number equals 9, because the lock is going to loop back. Image index equals current number minus 1. Okay, so I've included this because 0 is not on my lock, right? So we're starting at 1. So if you want to include number 0 as the number on the tumbler, then you just wouldn't need this code. You would be fine. But I have to do it that way because I have included it. And that's it. And then you can basically just duplicate this for your 4 tumbler objects and change the sprites, and they will all function the same way. Carefully place the tumbler objects over the lock controller object in your lock room so they line up with the background. Run the game and click on your lock tumblers. Ooh, nice. With all that out of the way, let's make it so the game recognizes when you've input the proper combination. Open up the step event of the global controller object. Since my game only has 1 lock, I'm doing it this way, but you could achieve multiple locks by having multiple global lock variables with different combinations for opening or different conditions for opening them. If room equals rm underscore lock and global.lock open equals false, open bracket, if obj underscore tumbler underscore 01 dot current underscore number equals 3, right? And I'm not going to say that again every time, but if obj underscore tumbler underscore 02 dot current number equals 1, if obj tumbler 3 current number equals 2, if obj tumbler 4 current number equals 4, right? So the combination, you guessed it, is 3, 1, 2, 4. Audio play sound, parentheses, SND underscore unlock, comma 1, comma false. Global.lock underscore open equals true, close the brackets. So basically, if the current number showing on each lock position is correct, we set global.lock underscore open to true. Our lock controller object code handles setting the latch sprite to the unlock state and counts down a timer. When that timer hits 0, we move back to the power box location. I included this to help guide the player a bit. It's optional though. Now, in our power box room, we need another zone called obj underscore zone underscore examine underscore lockbox. Oh, and before I forget, inside obj underscore power box, you know, the object in the background here, make a create event and input the following. Image underscore speed equals 0. If global.lock underscore open equals true, instance destroy parentheses obj zone examine lock. This will make it so the player can't go back to the lock room because we've already opened the lock. Inside obj zone examine lock box. So this is the create event for obj zone examine lockbox. And as you can see, it's very simple. It's just exit underscore location equals power box, right? Because we're going to go back to the power box location after we've clicked on it. And then the left released code is the following. So I have this here, and this just plays a shaking sound if the box is locked and you try to click on it. That just indicates that, there is an interaction possible. So, if global.lock underscore open equals false, and if the lockbox shake sound is not playing, audio play sound lockbox shake, right? Otherwise, if global.lock underscore open equals true, instance underscore create underscore depth parentheses x comma y comma 1 comma obj underscore vid underscore open box. So basically it's going to make a video of us opening the box, which is going to transition us to the state where we can actually click on the switch to play the end cutscene. And that's it for this code. Duplicate one of our previous video objects and name it obj underscore vid underscore open box. Swap out the video file for a video of the lockbox opening. Inside the alarm 0 event of this new video object, we're going to add the following code. Instance underscore destroy, parentheses obj zone examine lockbox. This will make it so we can't examine the lockbox anymore since it's now open. obj underscore powerbox.image index equals 1. This will set the powerbox background to the open sprite. obj underscore globe underscore controller dot cursor underscore lock equals false. Instance create layer, parentheses 900, 200, objects, obj zone examine switch. This creates a new zone object where our switch should be so that we can click on it. Instance underscore destroy, parentheses self. Finally, make a new object called, you guessed it, obj underscore zone examine switch, and make another video object called obj vid end cutscene. In obj zone examine switch, inside the mouse left released event, you'll create the obj vid end cutscene object, which plays our end cutscene. We're almost done. Open obj vid end cutscene, swap the video file with our end cutscene video, and for alarm 0, type game underscore end, since I want the game to end when the final cutscene plays. Let's watch what we've made. I click on the lock. I input the code. The lock opens. I click on the power box. It opens. I click on the switch. Et voila. By the way, I made this flying rust bird out of actual clay, wire, and nails, and used photogrammetry to scan it into my animation. That's totally unrelated. I just thought that was cool. Congrats on making it this far in the series. I do have one final optional video for you, which will demonstrate how to build Myst 3 style 360 panoramas. Thanks so much for watching this series. I hope it helps you create your own 3D worlds in Game Maker Studio 2. Please feel free to find me on Blue Sky at Uncanny Valerie or on itch.io at valerie-paris.itch.io. Remember, you can get access to the full tutorial project for free. Just check the link in the description. When you download the project, you'll get all of the code used to make this tutorial, including the Blender camera render script and the automatic image cropping script. Finally, you'll get a pack of cursors in 4 different styles that you can use to build your own point-and-click experiences. Donations are very much appreciated, but everything is totally free to download and use.